An investigation of waiting times at a doctor's surgery showed that 20% of patients waited 7 minutes or less, and 10% of patients waited 5 minutes or less. Assuming that waiting times are normal, find the mean and standard deviation of the waiting times. So, if we assume normal, what we're being told is that we have an unknown mean, an unknown standard deviation, but that if we go to 7 minutes, the probability here is 0.1. Sorry, 0.2, 20% of patients 7 minutes or less. And the 0.1 is if the waiting time is 5 minutes or less. So 5, and that probability is 0.1. Now we can find the mu and the sigma using these pieces of information and simultaneous equations. But the easiest way to do this is to make use of the standard normal. So I need to explain how before we can move ahead to do that. We have a distribution with mu and sigma squared. The standard normal has a mean of 0 and a variance, and therefore a standard deviation of 1. Now you can always change any distribution into the standard normal. Because you need it to be centered at 0, you start by subtracting mu. You need to change the shape. We discussed the shape in the intro to this section by making the standard deviation 1. And you do that by dividing by your standard deviation. In other words, Z is equal to your distribution, take away mu, divided by sigma. What our two diagrams over here show is that the probability that x is less than 7 is 0.2, and that the probability that x is less than 5 is 0.1. I can change these into the standard normal by saying the probability that z is less than 7 take away mu divided by sigma. So I use this to change that into a standardized normal value. Probability, of course, doesn't change. And we'll do the same thing here. Now, if I just draw another picture, so this is now the standard normal. If we just consider this part, this is 0.2, and what we want is the value here, because that will be what this is equal to. And as we saw in the previous example, we can do that using an inverse normal app. So we've got 7 minus mu over sigma is going to be equal to some value, and then we'll do the same over here, but use 0.1. So we want our inverse normal app. Mine has a tail setting, which I'll leave as left. The probability was 0.2, and it's the standard normal, so I don't need to change anything here. And that gives me negative 0.842. And then I'll just do the same with 0.1. I can just edit on my calculator. Some calculators you can do that and some you can't. Negative 1.282. And then these are simultaneous equations. So I have 7 minus mu is negative 0.842 sigma, and I have 5 minus mu is equal to negative 1.282 sigma. Let's just call them 1 and 2. I could use a prime if I want to indicate the fact that I've changed them slightly. And then if I do 1 prime take away 2 prime, I get 2. And of course the mu's disappear. And then I need to do negative 0.842 take away negative 1.282. That gives me 0.44. And so my sigma is going to be 2 divided by 0.44, which is 4.55, correct to 2 decimal places. And then to find mu, all I need to do is substitute back in. So from here, I can say mu is equal to 7 plus 0.842 sigma. So mu is going to be 7 plus 0.842 times the previous value, which is 10.83, correct to 2 dp.